Okay, congruent triangles is the last lesson. It's gonna involve proofs. So you're gonna have to use the concept we've learned so far, as well as some new concepts. So the five triangles are all the same size and same shape. On the right, just rotated, and so they are called congruent triangles. So remember, congruent shapes. The symbol for congruent is an equal with a similar symbol on top, and they're congruent when they are the same shape and size. Same shape and size. So that what that means is they have same corresponding angles and same corresponding sides. So looking at the flags here, each flag contains triangles which are the same shape and size, so corresponding triangles. So in the first flag, in Nova Scotia flag, where are the similar or congruent triangles? So there's A and A, B and B. If you imagine them going like this, right? Like finishing off. How about in Newfoundland? Where's our congruent triangles? How about the blue ones are all congruent, and the red ones are congruent. Flag of America, A and A, congruent triangles. Nambia flag, so these two are the same. Those are congruent triangles. Nova Scotia, A and B and B, opposite angles are equal. In this case, opposite triangles are the same, and same with Jamaica. A, and B. Okay, so what makes triangles congruent? So on each of the flags above, we marked which ones are congruent. So congruent triangles. A triangle has three sides and three angles. Two triangles are congruent if all pairs of corresponding sides and all pairs of corresponding angles are equal. Two triangles are congruent if all corresponding sides and angles are equal. So let's look at this one. So how do we write a corresponding? So we write it. This is how you write it if two triangles are congruent. So notice the symbol for congruency is in between, and it's always written in the particular order. So if it says triangle PQR is congruent to LMN, triangle LMN, it's saying angle L is the same as angle P. It has to be in that same order. So L and P have to be the same. Angle Q and M are the same. So it's really important the order we write our triangles. And then R and N are the same. It also says, and you can also go, side PQ should be the same as LM. Side PQ is the same as LM. Side QR will be equal to MN. So QR is equal to MN. And then P and R and M and L and N. So it's very important how we write the order. Okay? How we write the order. So how do we prove congruency? Well, there's three different properties that we can prove it. Now, if we have two triangles with all the angles the same, that does not prove congruency. So say this is a 90, 90, and we have 30, 30, 60, 60. It doesn't prove that they're congruent because the similar triangles have the same angles, but if we have no equal sides, we can't prove, right? You can take an enlargement and the angles would still be the same. So angle, angle, angle doesn't prove. So let me just give you another example. I'll take a shape. Let's find a shape, and maybe you'll take an interesting one. A star. Okay, I draw a star. Whoops. Draw a better star. Okay, right there. Delete this other star. Okay, and I take a clone. If I take a clone, then it would be identical. Okay, but what if I enlarge this shape? All the dimensions I double. All dimensions I double. So how can I do this? I want to be able to enlarge it. So if we did that, so I pulled it, everything's being enlarged at the same rate, the angles would still be the same. We'd have the exact same angles in all of these. But it doesn't show, like they're different sizes. So angle, angle, angle does not prove congruency. What if we have two sides and then an angle, but the angle's not contained. It's not contained between those two sides. Well, there's actually two ways to draw that situation, right? Because we don't know this angle right here, it has an ambiguous case. It could be either this way the 1 centimeter goes, or we can put the 1 centimeter that way, and both would give you that same angle right here. So side-side angle, when the angle's not contained, does not prove congruency. But there are three cases that do. If we have all three sides the same, then the triangles are congruent. The two triangles with all sides the same, automatically then their angles are also equal. If we have two angles and a contained side, so the side must be between those two given angles, that will prove congruency. So angle, side, angle. So notice angle, side, angle. And then the third case is side, angle, side, which is very different than, say, this case here. Right? Notice that these are not the same, because here our angle is contained between the two sides. So side, angle, side, there's only one way to make that, and so they would be congruent triangles. So these are the three cases. You need to know these. They should be on your study sheet. And in order to prove the triangles are congruent, we need to prove basically that we either have side, 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 three equal sides, angle, side, angle, so two angles and a contained side, or side, angle, side, two sides and a contained angle. Okay? So moving on. Let's look at all of these cases. Could we prove that they are congruent? Let's look at A. Notice we have angle, side, angle. Is that one of the three cases? Let's look it up. Yeah, angle, side, angle is right there. So angle, side, angle, yes, these are congruent. Yes, congruent. So congruent, but how? By angle, side, angle. How about the next one? Well, this is angle, angle, angle. Does angle, angle, angle prove congruency? No, it doesn't prove it. So not congruent, we don't know. We need to know at least one side. We always need to know at least one side. Could not prove congruent. Oops, I forgot some of the word. Not congruent. At least we don't know for sure unless one side's given in that case. Okay, how about this one? So I have side, side, and a side. Yeah, that's congruent. That's one of the three cases. So congruent by side, side, side. If we have three equal sides, corresponding sides are equal. Yes. How about this one? So we have a side here that they're the same. So that side's the same as this side. We have equal angles because of the 90. Do we know anything else? Notice how they share this side. They both share that side. So yes, it is congruent by side, angle, side. Side, angle, side. So we're going to have to do proofs. That means we're going to need to have a statement and then a reason. So usually these are going to have, they're four-step proofs, because you have to prove side, angle, side, or angle, side, angle, or side, 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 and then your statement that they are congruent. So let's do a proof for triangle ABD. ABD. So it's a parallelogram. Parallelogram. So that means this side is parallel to that side, and this side here, side AD, is parallel to BC. Now remember, BD is like a transversal. It's like a transversal. Okay? So if we have a transversal, remember, I'm just going to highlight and then erase it. Remember when we have parallel line, and a transversal, we have some equal angles, right? This and this one, what do we call those angles? X and X? What do we call that one? That would be called corresponding. So we can prove that those angles are interior alternate. And again, I'm going to erase this in a moment. Highlighter. We have parallel line, transversal. Right here, transversal. Then we can again prove that this one equals this. Remember the Z? So those two are going to be equal because, again, by alternate interior angles. All right, so I'm going to erase all that. Oops. Uh-oh. Did I lose it all? Nope. Okay, so we're going to start by saying these two angles are equal by alternate interior. So we have our statement and our reason. So we have two angles, right? So we better strategize this out before we start. So we said, okay, x and x are going to be the same from alternate interior. Y and y are the same from alternate interior. But that just gives me angle, angle. Angle, angle is not enough. We either have to have angle, side, side, side angle, side, or side, side, side. Obviously, side, side, side is going to be ruled out. Side, angle, side is going to be ruled out because we don't know two sides. But maybe angle, side, angle. Is there a side that they share that's the same? And that side, DB, it's a common side. They share that side. It's a shared side. So then there's our side, angle, side. Okay, so remember the order in which you write this is also very important. So let's start by angle X. So ABD, angle ABD is equal to, so notice I go A to B to D. So I'm going to go C to D to B. So equals angle CDB. And why is that? Well, what kind of angles are they? They are alternate interior angles. That's my reason. Alternate interior. All right, so we also have our other alternate interior. So Y is ADB, angle ADB equals angle CBT. Notice the order, okay? And why is that also because of alternate interior angles? And last, so we have our two angles and our contained side. So the order, watch how I write this order. So BD equals side DB, comparing the two triangles. Why? It's a shared side, or same side we could even write. Same line, same side. Right, same side. So what do we have? We have angle, side, angle. So we can say triangle. Notice the order. So ABD, similar to my angles. Triangle ABD is congruent to triangle CDB. Okay, why is that? What property did we use? We used angle, side, angle. Okay, so there it's proven. And so it wanted us to say, give our reason and our statement. So there's a proof, and you have to be able to do these proofs. Let's look at number 4. Actually, let's go to another example and come back to 4. So this example is not in your workbooks, but it's another really good example. So let's do this in class. So we have given is TP is, this symbol, remember, means perpendicular. Perpendicular, meaning a 90-degree angle. So TP is perpendicular to AC. So that means these are going to be 90-degree angles. Right? And AP equals CP. So they give us that AP is the same as CP. And we want to prove that our triangle is isosceles. Now, how do we prove a triangle is isosceles? And how can congruent triangles help us? In an isosceles triangle, we have two equal sides and angles. So if we can prove even just two equal sides, then we've proven that we have an isosceles triangle. So we want to prove this big triangle has two equal sides. So I want to show that this side is the same as that side, and then it'd be an isosceles. Well, in order to do that, we need our triangles to be congruent. We can't assume that they're equal. So we have these two small triangles. How can we prove congruent? And you always want to plan out your strategy ahead of time. So am I going to be using side, 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 side angle, side, or angle, side, angle? Now, right off the bat, I can tell you it's not going to be side, side, side because we don't know. We want to prove that those two are equal. They don't tell us that they are. So we can't use side, side, side. Okay, that takes care of that. How about angle, side, angle? Well, they give us one angle. Oops, let's not erase that. They give us one angle, but not two. So we need to somehow use side, angle, side. Do you see it? Here's our side, here's our angle, and then they share a side, shared side. So that's the strategy we're going to go. Always plan your strategy before you start your proof. Else, who knows where you're going to go with things, right? You always should know where you're going, and then prove it. So remember, we have our statement and our reason. Statement, reason. Statement, reason. And since we're proving side, angle, side, we should go in that order. Side, angle, side. So what side? So first, the two sides that are the same is AP is equal to, notice the order, CP. And why? Well, guess what? That was given. I love those reasons. Those are the best. Given. They told us it was. How about angle APT and angle CPT? Well, angle APT is equal to angle CPT. Why is that? What was given? Well, it was given that TP was perpendicular to AC. So both 90 degrees. Okay, there's my side part. Notice we have side, angle. Now we need another side. Just writing this on the side to remind myself, how am I proving this congruency? Because if they're congruent, then we can assume AT equals CT. All right, next one, sides. So what sides are equal? PT and PT, right? PT equals PT. Why? It's the same side. They share it. Okay, so now what have we proven? We've proven these triangles are congruent by side, angle, side. So make sure you write it in the order. So triangle APT is congruent to triangle CPT. Triangle CPT. You can also look at our angle up above to help that order, right? So you're writing it in the same order. And so how did we prove that these are congruent? Well, we proved side, angle, side. So now what does that mean? If these two triangles are congruent, what about these two sides? Well, they'd have to be equal. So we could say AT equals, notice the order, CT. Why? Corresponding sides on congruent triangles are equal. Okay, so you should be able to do all of this on your own. And since the two sides are equal, did we just prove that it's an isosceles triangle? Yes. So triangle TAC is isosceles. And what's our reason? We have two equal sides. Two equal sides. And what are the two equal sides? AT and CT. So now we've proven it is an isosceles triangle, and you have to be able to do all of this on your own. So you really want to practice those homework questions. Okay, one more example that's not in your book, and that's AE and BD bisect each other at C. AB equals ED. Prove that angle A equals angle E. Okay. All right, so what does this word bisect mean? Bisect. You bisect something. Not the same thing as dissecting. It's bisecting. It means to cut in half. Cut in half. So if AE and BD, so line AD and line BD, bisect each other, that means they cut each other in half. So that means that AC equals CE, and means that BC equals CD. They also tell us that AB equals ED. So do you see what we have? Side, 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 side. And we want to prove that angle A equals E. So if we can prove congruency, then A will equal to E. So we just need to basically do what we just said in a proof. So let's start with our statement. and then our reason. Okay, so let's start with saying AC equals EC, right? What we just did. So AC equals EC. So why are they equal to each other? Let's go back to the beginning. Well, AE and BD bisect each other. That's our reason. AE and BD. You can't just say given here. You have to actually, even if it was written above, the only time it's given if they actually say something like that. Okay, AE and BD bisect each other. Okay, good. And let's see what else. Now we want to say BC equals DC. BC equals DC we did next. So again, why are they equal? Same thing as above. AE and BD bisect each other. Right? Now you could actually, even if they didn't give you this, we could prove congruency. And just a little side note, right? These are opposite angles. Angle ACB and DCE are opposite angles. And so then we would have had side angle side. So they actually didn't need to give us that. But they did. So we're going to use it. So we can use side angle side. But we could have also done, oh, nope. Where is going on here? I'm deleting things. Not good. Okay, so they give us, let's use side, because that's what they give us. So, what did they tell us? They told us AB equals ED, and that was given. And so why do we have congruent triangles? Well, because of side, side, side. So how do we write the triangles? Be very careful. ACB, so I'm going, or let's go ABC. ABC, so 3 to 2, so EDC. Triangle ABC is congruent to triangle EDC. And notice how everything lines up, right? ABED, ABED, BCDC, BCDC. Okay, so that should all line up. Always double check all that. So now, can we say angle A equals angle E? Does angle A equal angle E? Yes. Why? Because corresponding angles on congruent triangles are equal. Are equal. Are equal. So there's our proof. So often our proofs are going to be 4, 5, maybe 6 lines long. All right, so you have to be able to do that. So let's go to that last question in your book. Number 4. The illustration shown represents a symbol for a communicator in a new TV space series. Looks like Star Trek, upside down. Use the information in the diagram to prove AD equals BC. AD equals BC. So let's see what we want to prove. We want to prove AD, this line here, equals BC, that line there. So if we can prove that certain triangles are congruent, then maybe we can prove that. So let's walk through it. So we want AD. So what triangle? There's a couple triangles, right? There's this one with this one. Okay, what else is there? So let's see what we know of those triangles. We know common side. We know 3 and 3. We don't know any angles, though. So that might not work. How about big? Let's look at the big ones. So we want to prove AD. So maybe what about this triangle? And then this triangle. So we know 7 and 7. Okay. We know 4. This is 4 here. This is 4 here. So two sides. They also share an angle. So could we use that? Could we use that? Okay, so there's a few ways we can go about it, right? But basically we want to prove some congruent triangles. We could also maybe do the small triangles. So let's look at the small triangles again. So those big ones could work. Look at look at the small ones. So they both have 3 centimeters, same side, and that line. Okay. And again, the small triangle, 3 centimeters, same line. So I have side, side. I would either need this angle to be this angle. We only can prove that if we know these angles are equal. And do we know those angles are equal? And the answer is yes. So we could go about this way. Why? If these are both 4, this is an isosceles triangle, meaning that those two angles are equal. So that's another way we can go about it, because then we can say these angles are equal, and we'd have side, angle, side. There's a few ways to prove this one. Okay? So we're going to prove then that we have some congruent triangles, and then if we have congruent triangles, then AD will equal to CB. AD equals CB. So let's start with the smaller triangle. Now remember, I need to prove first that this angle equals this angle before we can prove, oops, that's not the big one, that these two triangles, the green and the red, are congruent. So we want to start here, because then we can say angle BDC equals angle ACD. So where's our statement and then our statement and our reason? Okay, so first statement is that DCF, angle DCF, is equal to angle FBC. And why is that? Well, because we have an isosceles triangle, and that triangle is FCD, equal sides of 4. Okay, so the opposite angles of isosceles triangle of the opposite equal sides are also equal angles. So we have an isosceles triangle, so those are both. So then we want to prove, okay, so then what is angle ACD going to equal to? Well, it'll be 180 minus angle DCF. So angle ACD equals 180 minus angle DCF. Why is that? That's because of a straight angle. And angle BDC would also be 180 minus angle FDC. Okay, so therefore, and these two are equal, then that means angle ACD equals angle BCD. So both reasons there were straight, and this is transitive, right? The transitive property. So what we did here was if BCF equals FDC, and they're both 180 minus that, and these are the same, then these two have to be equal. So that's what we just said, transitive property. Okay, so now we know that this angle here is the same as that angle here. We just need our two sides. AC equals BC. They're both 3 centimeters. AC equals, BD, both 3 centimeters. And CD equals DC. Why? They're the same side. So what did we just prove? Up here was that angle. We have our side, but it actually is side, angle, side, because our angles contained. So we have congruent triangle. So triangle ACD is congruent to triangle BDC. Notice the order again, AC, BD, AC, BD. Right, should all line up properly. And so how do we prove that? We proved it by side, angle, side. And then now, because those are congruent triangles, we could say AD is actually equal to BC. And how do we prove that? Well, corresponding sides on congruent triangles are equal. congruent triangles are equal. And there's our proof. It wasn't the only way to prove it, it's just one of the ways. And there we go. And so that's the end of this lesson. So the homework is 1 to 13. Make sure you check your homework online and that you really go through, did I do my proofs correctly? Because these are so important.